hey, what's the particular solution to this differential equation with this initial condition? Well, you know how we solve differential equations? We separate the variables. So separating here, if I divide this over, it's got to be with the dy. No other way to do that. So that's going to be 1 over y squared, or y to the negative 2 over here. And then the dx is going to move up here with that x. Now we find our antiderivatives. The antiderivative of this, bump the exponent up 1, divide by the new exponent, which is negative 1. Antiderivative of x is x squared over 2 plus c. Now they have them all solved for y, so I think we better do that. So let's see. If I multiply through by the negative 1, so negative x squared over 2, I have the plus c can withstand being multiplied by 1. I'll call it c1 because it's not exactly the same c as this. And then this is the place where things can go easily wrong for us, I think. You've got to be very careful here. I need to flip this over. And when I flip this side over, because addition is the weakest operation, that's negative x squared over 2 plus c1. You cannot flip them over separately. That just breaks algebra. Sorry. So initial condition here, if I plug 2 in for x, I should get 1 for y. So 1 equals 1 over plugging 2 in here, that's negative 4 over 2. That's negative 2 plus c1. So if this is equal to 1, it's got to be 1 over 1. You can do some algebra here, but I like just thinking about it. So 1 over 1, that's got to be 3, right? Because I need 1 over 1. So that would have to be 3. All right, so that means my solution is this. Well, that's not any of the answers. So can I get it to be the same as any of them? They don't have any like complex fractions, so if I multiply the top and bottom of this by 2, it would alleviate that problem. 2 times 1, and then distributing the 2 on the bottom, minus x squared plus 6. And I think we can see pretty easily that that's the same as d. Number 24. Which of the following series converge? Hey, we just talked about this. So the partial sums of this, it's 1, 0, 1, 0. So this does not converge because the partial sums have to get closer and closer to something. So this is no-go. We see this sometimes when we check endpoints. How about this one? Well, here's your general term. So by limit comparison, that's where you only care about highest powers, right? So here, this is the same as 1 over n, which is the harmonic series, which does not converge. So this is related to the harmonic series. How about this one? Well, let's see, that's 1, 1/3. This is just geometric. I'm just multiplying by 1/3 each time. So this is geometric. And the r is equal to 1/3. So that converges. So only number 3 does. Number 25. Slope of the tangent line to the polar curve r equals that, where theta is equal to pi over 6. Okay, if you want to do slope is still dy dx. So here, you got to parameterize this. So let's see. X is equal to r cosine theta, and y is equal to r sine theta. So x is equal to r is just cosine, so that's cosine squared theta. And y is equal to cosine theta times sine theta. There's a trig identity you could use there, but let's just pretend we didn't notice that. So we'll just write it out like this. Right? So if you want dy dx, I got to find the derivative of this, put it over the derivative of this. So dy dx is equal to dy d theta over dx d theta. Okay, so let's find the derivative of this. So dy d theta, using the product rule, derivative of the first times the second minus the first times, plus, but it's going to be minus. Sorry, just saw that coming. That's what you get using the product rule there. And then here, using the chain rule, that's the same as cosine of theta squared. So derivative of something squared is 2 times something times the derivative of what's inside, which is negative sine theta. All right, I think here at this point it would probably be helpful for us to just make sure we know what is the sine and cosine of pi over 6. So sine of pi over 6 is 1/2, and the cosine of pi over 6 is the square root of 3 over 2. All right, so let's see where we get from here. Don't mix up the ups and downs here. We need this first on the top. So cosine squared theta, so that's this squared. So let's see, that's square root of 3 over 2 squared is 3/4. Minus sine squared, that's that squared, 1/4. Okay, and on the bottom, I've got 2 times the cosine of theta times negative sine of theta. So 2 times the cosine of theta times negative the sine of theta. And let's see what we can do with that. So 3/4 minus 1/4 is 2/4, or 1/2 over, see those 2's cancel, so square root of 3 times negative 1/2. The 1/2's cancel, so I got 1 over negative square root of 3, which is B. Boy, they're working you in this set, huh? It's a lot of work for one multiple choice. Well, here we go. If you know how to do this problem, it's like the easiest calculus problem in the world. So the derivative of an integral, those two things cancel out, and it's just this. But this drops in here. And the one thing that's so easy for us to forget is that if this thing right here is not just a plain old x, well, it's dropping in here. It's like becoming the what's inside, and we're taking a derivative. So I have to multiply by the derivative of what's inside. So the derivative of the square root of x is 1/2 x to the negative 1/2. So got to figure out which one of these that matches up to. So let's see. That's 1 over 1 plus the square root of x squared is just x. And then I've got 1/2. And then x to the negative 1/2 is 1 over the square root of x. So that's that. Fundamental theorem of calculus. That's what we called part 1. (27) What's the coefficient of x squared in the Taylor series for sine squared x? About x equals 0. You could find a bunch of derivatives of this, and you don't have to go that far. You could definitely do that. That's a way of doing it. I don't discourage you from doing it that way. I'm going to do it a different way. I know what the series sine squared x means sine x times sine x. And I know what the series for sine x is. It's odd, right? So it's x minus x cubed over 3 factorial and so on. So I just need to multiply that series by itself. And we could find a whole bunch of terms for that, but I don't have to go very far because x times x is x squared, and clearly I think you could convince yourself pretty easily that everything else is going to be, there's going to be something times x to the fourth, x to the fourth. There's no other like terms to this. So what's the coefficient of that? It's just 1. You want to see it the way, like making it from scratch? All right. So if f of x is equal to sine of x squared, then f prime of x, now we're interested in the coefficient for x squared, so that means we're interested in this term, right? So here the first derivative, 2, derivative of something squared is 2 times that thing times the derivative of what's inside. And boy, this is easier at this point. You can do the product rule, but if you know your trig identities, man, that makes it easier because sine 2x cosine x, that's the sine double angle. So the derivative of that is 2 cosine 2x. So what does the second degree term look like? Well, the second degree term is f double prime of 0 over 2 factorial times x squared. So plugging 0 into this, cosine of 0 is 1, I get 2 over 2, which is 1. So you can do it that way too. You can do the product rule here too. You still get the same answer. All right, last one. Function h is given by this, and h of 1 is equal to 2. Well, thanks very much. We could have figured that out. If h inverse is the inverse of h, that's kind of funny. What is the value of h inverse prime of 2? Okay, so remember this game? I've got a point 1, 2 on the h function. And then on the h prime function, or sorry, on the h inverse function, there's going to be the point. Inverses are switching x's and y's. There's this point. The relationship between the slopes is when you swap x's for y's, then dy dx flips upside down because you're switching x's and y's. Rise over run becomes run over rise. So if I can find the slope of either one of these, then the slope of the other is just the same thing but upside down. So I think I can find the slope here because h prime of x is just 5x to the fourth plus 3. So h prime of 1 is equal to 8, which means that over here h inverse prime of 2, right, because the x's and y's switch places, that's the upside down of this. It's just 1/8. Boy, there's a lot of stuff to remember, isn't there? You can do it.